after me. All right. Transformations of quadratic functions. The good news, they're no different than every other one we've done. Absolute value, radicals, even circles to a point. So graph the function, identify the vertex, the axis of symmetry, and the direction of opening. I'm going to be honest, we shouldn't need the calculator here. Or if we do, maybe for number 2, because it's a little funky. But other than that, I should be able to look, especially in vertex form, and be like, all right, opposite of h plus k. So switch it in the parentheses, keep it on the outside. -1, -2. My a value is -1. Okay. Does not mean I go down 1 and go each way, down 1 and go each way. We're not making an absolute value graph. These are the ones where we talked about before with that 1, 3, 5 pattern that I'm working with, which basically means that's telling me in a normal parabola that I'd be going up 1 and over 1 each way, up 3 and over 1 each way. But it all depends on the a value. So with that pattern at -1, it just means we're multiplying the entire pattern by -1. So now we're going to go down 1 and over 1 each way. But then we're going to go down 1, 2, 3 and over 1 each way. If I have room, 1, 2, 3, 4, well, 5, that's close. 1, 2, 3, 4, 5. Hardy, can't I just put this in my calculator and once I know where the vertex is, see the symmetry and use the points? You can. But again, does that become a time issue for you sometime on a quiz or a test? Maybe. If you're real good at it, maybe not. But those are the types of things I'm trying to get you to make sure that we're in good shape. Moving ahead. Vertex form again. Okay. Opposite of h plus k. Now, 1/2 is a little crazier. Because now, if I go through and I multiply 1, 3, 5 by all of these, you're like, okay, this is kind of weird. 1/2, 3 halves, 5 halves, that's not going to be easy to graph. But again, that's just the up-down part. So I'd go down 1/2. Oops, not down 1/2, Hardy. That's positive. Up 1/2. That's going to be kind of squished. Then up 3 halves is up 1 1/2. It would get me back on the regular points that I'm using. But if you're just looking at that going, yeah, no, not happening. This is where, again, we have more tools. So, if we need to use one of the tools now and then, okay. I know where my vertex is, so I'll just pull my chart up, get my vertex in the middle. There's my symmetry. And even if you just wanted to use the whole numbers for your graph, that's fine. If you used 3, 5, and -1, 5, okay, that's these two. And then you could go to like 5, 11, and -3, 11. You're there. But you've got to know the basics, okay? We've got to be able to get the vertex to get that done, and we've got to know the tool well enough that we can get to it quickly. How many points can you make it with?
Well, no, I don't have to graph it, but for like the first one, I only did 1 point or 2 points, and I got the same thing.
As long as you're accurate with it, yes. Like, I don't want to see where, oh, I've got my vertex and my parabola is like this, and it's like a line or two off on your next 2 points because you were just kind of guesstimating, or am I misunderstanding?
No, so like with that number 2, when it goes off the graph, do I have to graph the one off the graph?
No.
I just do the half that.
Yeah, as long as you have 3 at least to base off of, you should be okay.
Okay.
Yeah. Absolutely. Okay. Write the equation of the graphed function. Now, this gets a little more interesting. So, I look at this and I'm like, all right, here's my vertex. There's my h and k. I know when I do the equation, I'm doing it in vertex form. I got h and k right here. So at the very least, when I'm graphing this, or when I'm making the equation for it, x opposite of h squared and k, don't change the sign on your k. 2/3 of this should be done quick and easy. Now, the other part that I got to think about, it's a little more interesting. Because you're like, okay, now what? Well, here's my first pair of points that I'm going through at those crosshairs. So I look, I'm like, all right, so 1, 2, well, Hardy, I went up 3, and then I went 1 each way. We just pop in the 3 for the A. Wherever that first set is. Sometimes you got to watch. You may be given a second pair instead. We'll chat when we get to those. But for the most part, once you find that first pair, you're in. You're good. And you're golden. So that, again, more review than anything else, but we tend to come back around that way. So now it's going to turn into a pattern game. Write each equation in vertex form. This, standard vertex. Give the coordinates of the vertex, the axis of symmetry, and the direction of opening. You're like, Hardy, we've done this already. Okay, you're right, but let's kind of see some things here. Normally, to get my vertex, I do the opposite of b over 2a. Ooh, what's the b value on number 4? Nice. The b value is 0 because there is no x term. So if the b value is 0, 0 divided by, I don't even care what this is really, is 0. So my vertex, if you plug in 0 for x, 2 times 0 squared is still 0, plus 4 is 4.
Where do we normally find b?
It's the number in front of x. And we don't have a regular x term here. That's why that b value is 0. But here's an even better part to this. So you're like, well, if I put that in this form, you're like, this is kind of weird. So y equals, I already got my a. I don't have to find that. X minus h squared plus k. Now, could I leave it that way? I mean, I could. Right. And so you rewrite it and you're like, well, wait a minute. If I change it back to x squared, Hardy, it's the exact same thing I started with. It is. So wait, does that mean that any time that the b term is gone, it's not there, it's 0? That this already is in, I guess we'll call it vertex form, even though it looks like standard? Yeah. And wait a minute, does that mean too that my vertex is just going to be 0 and whatever that y-intercept value is? Mm-hmm. So you see this, we don't have to go through all the math. All you're going to do is you're going to go, sweet, my vertex is at 0, 5, because there's no b value. That is the vertex form already. I don't have to do all that work. Now again, if I do the work, am I going to get it wrong? No, I'm still going to get it right. But again, I'm looking for those ways to shorten the process up. That's why we do some of them. So be aware. Be aware of your surroundings. It sounds like I'm talking about stranger danger, but I'm not. It's function danger, I guess, if we're going to call it something. Okay. Write the quadratic in vertex form. Give the coordinates of the vertex, the axis of symmetry, the direction of the opening. Oh my gosh, so much stuff to do. We got this. All right. Let's kind of separate this off a bit. This time we have a b value. Okay? My b value is 4. So we got the opposite of b over 2a. Negative 4 divided by 2 is negative 2. So, first things first. X equals negative 2. There's my axis of symmetry. Yes, I have to have x equals with it. I guess you could have circled that, but we'll play this through. So now for my vertex. I have the x value. I think we're capable of plugging this in. So negative 2 squared would be 4, plus negative 8 would be negative 4. Could I just look that up in my calculator? If I wanted to use the calculator, I could. So I got my vertex. I got my axis of symmetry. And is this parabola going to be opening up or down? Up. Go ahead, sure. Well, but remember, the formula for this is the opposite of b over 2a. C doesn't come into play.
What about on the other one
We didn't have a b value. Yeah. C does not matter at this point. It will, and there will be some that it comes into play on, but other ones there's not. And the other thing I want you to be aware of, because I know this freaks some of you out when you get funky fractions and decimals, that's going to happen. So that's the next one we're going to do. We're going to do 8, because it gets weird. So, same process. X is the opposite of b over 2a. Hardy, do you care if I go to a decimal? I do not. I'm not going to, but if you do, I don't care. So x equals negative 3/2 is my axis of symmetry. My vertex then, now am I expecting that you're going to be able to calculate that and just figure that in your head off the bat? No. So what are my options, Hardy? And this is sometimes why these lessons take longer than you'd like them to. I can either literally just go in and type, not that though, okay, literally just substitute the negative 3/2 in everywhere that there's an x and get to the answer. Or some of you have been more comfortable going to the graphing function. All you've got to do, if you know this value, you're like, Hardy, that's not going to be in the chart. You're right. If you hit just trace, not second trace, just trace. Once it's done thinking here, I can type in any x value I want, and there's the decimal equivalent. Those are the same. Like I said, I don't care if you use fractions, decimals, a mix. It makes no difference to me. Are we getting to the value that we need?
Yeah.
That's the whole thing. And that's also opening up because our a value is 1. Oh, I didn't put it in vertex form. Nobody's yelling at me about this stuff. I'm like, wait a minute. Write it in vertex form. Oh, Hardy. The same format we've been using here since the front. We're going to have to flip back over and look. X opposite of h squared plus k. Doesn't that look like fun? And the same thing over on this one. I'll write it now that I saw it. Y equals x opposite of h squared, and then plus k. That's all we're doing. We're making the connections between the vertex form, and how all these pieces come together. And so, the only twist to that, these are straightforward because it's just x squared. Now, it doesn't mean if there's a number in front that all is lost. But what I do want to do, I want to look at these, or at least 10, Same exact process. We're still doing the opposite of b over 2a, except we actually have an a value this time that isn't 1. Negative 6 divided by negative 6 is positive 1. So there's my axis of symmetry. Plug the 1 back in, whether it's using the graphing function or just, again, maybe just using your brain on this one. I don't know. I mean, it depends on how comfortable you are with some of this, but... So I've got my 1, negative 6. I've got my vertex. My a value is negative 3. So we're heading down. Now, write it in vertex form. Okay. Y equals, this time, your a value is still the same. That's got to be included here. So negative 3 is still your a value. That will not change. And now use your vertex. X opposite of h squared plus k. What's that? In a moment, yes. So once I get here, again, your choice, 1, negative 6. There's my first point once I'm back up here. But my a value is negative 3. 1, 2, 3, 1, 2. I'm not fitting more than 3 points this time because it kind of got me way down here. So if we do that same thing here, let's kind of play combo. X is the opposite of b over 2a. Negative 12 divided by 4 is negative 3. So that's my axis of symmetry. How I go about getting my y value now, again, you have options. You can type that into y equals and go to the chart. You can type in y equals and trace. It don't matter. I'm sticking with this though because, again, this would work on any calculator. I don't have to have a fancy one to be able to make this happen. Make sure I typed it in right. So I've got my vertex. There's my a value. So my a value is positive. We're opening up. I can get all the answers from just a couple of things. Y equals a x opposite of h squared plus k. There's my vertex form. And again, at this point, you can type it into the calculator in this form if you want. But I don't believe that we need it. Because again, remember, with our 1, 3, 5 pattern, you're multiplying each of those by your a. So 2 times 1, 2 times 3, 2 times 5. 1, 2, 3, 4, 5, 6. This time I can get another point in.
I can just skip pretty much all that process if I just plug the first equation into the calculator.
You're still going to need to tell me this, but yeah, but I'm telling you, if on a quiz and I've got 25 questions and putting this stuff on, you're having to play with calculator buttons and moving around and stuff, you're going to be pressed to finish. So I'm just saying, if you're doing that at the start until you're making the connections with things, that's sensible. I wouldn't trust it for everything, though. It's like anything else. When you first start to trust stuff, then it's going to turn bad on you at some point. So just keep messing with it, though. But at the start, if that helps you make some connections, that's a fine thing to do. So you're like, okay, Hardy, a lot of this was review, but now we're kind of connecting between the parts. We've done the transformation stuff over and over and over. It doesn't matter if it's a quadratic or any of the other ones. Okay? If it's inside the parentheses, going on over here, it's the opposite of what we think. Left is positive, right is negative. You're like, okay. If it's outside the parentheses afterward, that's up and down, exactly like what it looks like. If the negative's in front, we're reflecting over the x-axis. If there's numbers in front of my x squared, we're vertically, okay, up and down, stretching or compressing. Stretching if it's bigger than 1, because it's big. And if it's little, it's kind of making us squish down, and when we squish down, we're kind of compressed like a can is when you squish it. Here's the new play. If the negative's inside your parentheses, now we're not reflecting this way, we're reflecting over the y-axis. We're going to be flipping this way. And you'll be able to see that. We're going to see it on the calculator. If your stretches or your compressions are inside the parentheses, we're going to be taking these and we're going to be squishing this way instead of up and down. We're going to be squishing sideways. And again, we're going to see multiples of these. But you might want to make sure, bend your note page over. You're going to want to keep this handy because as you're starting this, it's going to be a little challenging at the start. But as I keep saying over and over, and I'm going to keep saying it, the more you keep messing with it, the easier it's going to be. So, no pictures.
What?
No pictures. I mean, you can type this in on your calculator. Look at it. I mean, but look at a picture. But what we're going to try to do, and what I'm going to do, is I'm going to put our chart here on the bottom so you can kind of see what we're up to. We'll start normal. What are my two shifts on number 12? Right 2, up 3. Perfect. Okay. Now, number 13, there's 3. Bless you. What are my 3 transformations on 13? Reflect over the x-axis. That's the negative in front here. Down 1 is 1. That's true. Bingo. Vertical stretch of 2. Okay? The stretch doesn't care about positive, negative. The positive, negative determines where are we reflecting. So that's why it looks like there's only 2, but there's actually 3. So we got to be careful. Okay, now let's start throwing some of the new ones in. How about 14? There's 2.
Reflect over the x down 4.
Okay, I'm with you on the down 4. Where are we reflecting? Reflecting about the y-axis. Hey, there you go. There it is. Yeah, inside is y, outside is x. You'll be able to graph and do.
The square root, like.
Yeah, same thing. If it's inside of anything, whether it's a radical, an absolute value, parentheses, it's no different for any of them. So with that in mind, what are our 3 on number 15? No reflecting, no negative. Okay, up to right 1. Okay, now what's the 3 do? Close. Horizontal stretch. 3, because it's inside your symbol. If it's inside and there's an A value, a coefficient, that's a horizontal stretch, compress, when we're doing those. Okay? All right, let's go back to one normal one, and then we'll wrap up here. All right, 16, all normal. Three things. Left two, up one.
Wait, I got it.
Negatives are reflects. Where am I reflecting?
I don't know. It's equals. It's outside the parentheses.
It's outside, okay.
But the X
Don't, I just care where the negative is.
reflect over the X.
Reflect over the X. So if this would have been negative X inside the absolute value, it would have been reflect Y, like we had here. Where it's positioned matters. And this will help when you're even doing your graphing on things. We will be graphing cubes a little bit further down the road. We're in the quadratic unit right now. We will get to larger exponents with things.
Yeah, good. Next semester.
So we're getting cubes. Cubes are going to look like this. Cubes are going to look like snakes when we graph them.
Would that be like a cube?
No, it is not going to look like a cube. No, it will not look like a die when we graph them. No. We're not going three-dimensional on you here. Okay, I'll warn you in advance. Next quiz, yeah, lots of this. I'm just saying in advance, so we're not scared.
And are we, I assume we're probably not going to have access to that, or?
To the chart, no.
It's
That's where the practice comes into play. Most of it, if you're looking at this, this should not be new. So you got three new things to just play in, and they're just inverses of stuff. We just got to start connecting, okay, inside versus outside just changes vertical and horizontal. We'll talk about it a lot.
What's the first quiz for this?
Your next quiz, because we just got done with the first quiz. So your next quiz for this, we're probably looking.
Not this week, right?
Oh no,
Okay,
no.
That's all I need to hear.
Okay, simple enough. All right. Given a base graph, given a parent graph, what is the new equation if the function is, oh boy, shifted vertically down 3, horizontally right 5, and reflected over the x-axis? Okay. Let's do this in bits. We know x is going to be involved somehow. Okay. Down 3, so we know it's squared, so down 3 we know has to be at the end. Right 5, what am I going to put in the parentheses? Okay, because minus is right when we're inside, just like it is here. And reflected over the x-axis. Just slap a negative in front. Reflect over the axis, right 5, down 3. Bingo. Last one, and you will have survived. I loved the questions and the back and forth we had. It's good. Radical this time. All right, let's see. Up 3, outside the radical. Left 2, oppo, inside the radical. And reflect. Oh, I should have said reflect about y instead of x. Well, I did. Reflect about x. And we're there. That's it. Hallelujah. All right. So, you know what I'm going to say, and I'm going to say it with more vigor today. Maybe that's what I have to do. I don't know. I've done that before. I've jumped on the table. I've done a lot of strange things. Oh yeah, I've jumped up on the table. You can, yeah. Jumped up on the table, scream, yell. Yeah, I've done all that stuff. It doesn't really get you far in your way.
Works for law firm.
That's when I was a younger, more of a hothead. I can tell stories of that when I'm off of video here. So okay. So on 3 and 4, you've got a whole lot of similar to what we just did. Again, if you are having any struggles, do not just do the bare minimum or skip the stuff you're struggling with. Go double down on that. That's how you're going to get better and be more comfortable. Double down, and then if it's still not working, talk to me. Not after the quiz. Talk to me before, so we can make sure that we get this stuff down.